Hi everyone, I'm Jinling Sun, a PhD student from East China Normal University. Today I will introduce my work, which is conducted under the supervision of Ge Guangpu and Ting Su. Android system offers 9 major user-configurable setting categories for controlling the device and the apps. The apps on the device are expected to adapt their behaviors to cater to these setting trends and ensure reliable function. However, since setting trends are diverse and may happen at any time, even well-tested apps may suffer from setting issues, which reside in the apps and are induced by the trends of settings. To understand these setting issues, we conduct an empirical study on 180 popular open-source apps and found that 90% of apps were ever affected by setting issues. Furthermore, over 70% of these setting issues lead to non-crashing consequences. However, due to the lack of test oracles, existing fully automatic app testing tools can hardly uncover these non-crashing bugs. To fill the gap, we designed and introduced setting-wheel metamorphic fuzzing, the first fully automatic testing technique to overcome the oracle problem in detecting setting issues. Metamorphic testing is a property-based software testing approach to addressing the test oracle problem. In our scenario, our key observation is that the app behaviors should keep consistent if a given setting is changed and later probably restored. Otherwise, a likely setting issue happens. We leverage this observation as one kind of metamorphic relation to overcome the oracle problem. We formalize our technique as follows. Let E be a GUI event. Let L be a GUI layout. A sequence of events can be executed on an app to obtain a sequence of GUI layouts. Then we inject a pair of events EC, EU into the C test to obtain a mutant test, where EC changes a given setting and EU restores the setting. By comparing the GUI consistency between the C test and the mutant test, we can detect setting issues. Formally, the oracle checking rule is defined as: if there exists one GUI event EI, and its target webget cannot be located on the corresponding layout LI plumb of the mutant test, then a likely setting issue is found. We realized our approach as a tool named SetDroid, which contains 3 main models. The test executor explores the same app on 2 identical devices at the same time. The setting chain injector randomly injects a setting chain event into device B and restores the setting when the app asks user to change setting by an allowed dialog, which is demanded by Android designed guidelines. The oracle checker checks whether the oracle checking rules is violated. We give an example of a real setting issue detected by SetDroid. Cucumber has a candidate model that can record some events. The seed test shows that a user can normally delete a certain candidate event. However, if the user turns off the candidate permission in the system setting before opening Cucumber and regrants the permission when Cucumber reminds the user to open the permission, then the user cannot delete the candidate event normally. SetDroid has been evaluated on 26 popular open-source apps and detected 32 unique previously unknown setting issues. We further apply SetDroid on 5 highly popular industry apps with billions of monthly active users. SetDroid successfully detects 17 previously unknown setting issues in these apps. 39 out of 49 SetDroid detected bugs are non-crashing bugs, which could not be detected by existing testing tools. To facilitate reviewing and replication of our work, we have open-sourced SetDroid as the link in the right corner. Thanks for your listening.